All right, number 4, last one. Identify the intervals in which f of x is equal to the quantity x minus 2 to the 2/3 is increasing or decreasing. All right, so first we're going to take our derivative. So f prime of x is equal to, again, this is going to be a plain M&M chain rule, so this will be 2/3 to the negative 1/3. And then we have our chocolate, x minus 2, and then derivative of the chocolate, which is 1. So you don't technically have to write this. And we're going to set that equal to 0. So I have 2/3 times, and then I'm going to take care of this guy right here. It's negative, so that means it's from the denominator. My 1 is my coefficient. And then if it's a third, that means it's the cube root. So we're talking about in the denominator and the cube root of x minus 2. Well, this is going to be 2. So 2 times 1 is 2. And then we have 3. That's part of my 2/3. Here's the cube root of x minus 2. Well, if you look at it, when you set it equal to 0, we're setting the numerator. And so there's no way that 0, if I write that as a fraction of 0 over 1, is ever going to equal 2. That just doesn't happen. So in terms of a critical value, I don't have one where f prime is equal to 0. Okay, because 2, I can't set 2 equal to 0. It doesn't make sense. But what I can do is find where my function doesn't exist. And so what that means is I have to set my denominator equal to 0. So I have 3 times the cube root of x minus 2 is equal to 0. Divide both sides by 3, and I'm left with the cube root of x minus 2 is equal to 0. If I want to get rid of the cube root, I need to cube both sides. And so I have x minus 2 is equal to 0. That means x is 2. So that's where my derivatives domain breaks down. So I have a problem there at x is equal to 2. It's in the denominator, so it probably tells me I'm going to have a vertical asymptote at 2. So this is where my function, my derivative, when I said f prime is at x, doesn't exist. So we're going to go ahead and create our number line. And we're going to include 2. And above it, I'm going to write D and E, because that just reminds me that's not an x-intercept. It's where I'm probably going to have a vertical asymptote. It's where my derivative's not going to exist. And now I'm going to list my factors. And so I have 2/3, which is always positive. And then I have 1 over the cube root of x minus 2. Alright, well, 2/3, I'm going to pick a number to the left of 2, let's say 0. 0 is an easy number to work with. Well, 2/3 is not multiplied by anything, so he's always positive. And then I'm going to plug in 0 into that function. So I have 1 over the cube root of 0 minus 2, which is 1 over the cube root of negative 2, and that's okay. That's going to give me a negative answer. I can take the cube root of a negative, and that'll give me negative. So we're talking about 1 over the cube root of negative 2, which is going to give me a negative answer. That negative is going to come out because I can have a negative times a negative times a negative. That's what the cube means. That's okay. And now I'm going to pick a number to the left of 2. I don't know. I'm going to pick a big number. Let's say 10. Again, I have nothing to plug in for with my 2/3. So he's still going to be always positive. And then I'm going to plug in 10 into my cube root. So I have 1 over the cube root of 10 minus 2, which is 8. And so the cube root of 8 is 2, so it's 1 over 2, which is positive answer. And so a positive times a negative gives me a positive, or excuse me, a negative. I don't know why I said that. Negative. A positive times a positive gives me a positive. And so in terms of my f, if my slopes are negative, that means my function is decreasing. If my slopes are positive, that means my function is increasing. So f is increasing on to infinity, because, I'm going to put BC for because, f prime is greater than 0, or is positive. F is decreasing, I'll put DEC, on negative infinity to 2, again BC for because. F prime is less than 0, or negative.